Welcome back to the deep dive. Today, we're taking a close look at some really specific materials you sent us. It's excerpts about a cochlear implant insertion simulator.
That's right. We're going deep into the technical side of what sounds like an interactive web app.
Yeah, an app designed to simulate something incredibly delicate, inserting the electrode array during cochlear implant surgery.
Exactly. And it's a really crucial step in that whole process.
So our mission here, just using the source material provided, is to unpack the technical features, the parameters it tracks, and what this simulator is actually for.
Mm-hmm. And the source reminds us the core idea of a cochlear implant is helping folks with profound deafness by electrically stimulating the auditory nerve.
Right. And this simulator focuses purely on getting that tiny electrode array safely into the cochlea, the inner ear structure.
And the source gives us a couple of tech hints straight off. It mentions 3JS.
Ah, for the 3D rendering, right. So
Yep.
you can actually see the cochlea model and the array.
Precisely. And also chart.js, that suggests data visualization.
Yeah. Okay, so displaying measurements, graphs, that sort of thing.
That's the idea. So fundamentally, it's an educational tool.
Yeah, letting someone, virtually try out and understand the mechanics, the forces, the key numbers involved in this very specific surgical action. Let's maybe start with how you actually interact with it.
Okay, so the main way you interact, according to the source, seems pretty intuitive for this kind of simulation. You click and drag
Click and drag aware.
vertically, either on the metallic electrode rings themselves or on the clear silicone carrier holding them.
And dragging down inserts it further.
Yep, simulates insertion. Dragging up simulates retraction. Pulling it back out. Makes sense.
And when you're not dragging the array, I assume you can look around.
Exactly. Standard 3D controls kick in then. The source mentions orbiting the view with the left mouse button,
Okay, spinning around the model,
panning side to side with the right button or a two-finger drag,
shifting the view.
and zooming in or out with the mouse wheel or a pinch gesture. Pretty standard for 3D viewing, essential for checking things out properly.
Absolutely.
Yeah.
But the really core technical part seems to be the feedback it gives you, right? The numbers.
Oh, definitely. The source calls it a HUD, a heads-up display, usually top right corner, it says.
And that's showing the critical data in real time, like what specifically?
Two key things mentioned, depth and force.
Okay, depth measured in millimeters.
Millimeters, yes, very precise. And force measured in millinewtons.
Millinewtons. Wow, that's a tiny unit of force.
It really is, and that's crucial. It highlights the extreme delicacy needed. A millinewton is like barely anything. The force of a tiny water droplet, maybe?
So tracking force at that level tells you just how fragile the cochlea is.
Exactly. And the HUD doesn't just show numbers. The source says it uses color-coded messages, too.
Like warning signals.
Kind of. Messages like safe to insert when things are okay, but also warnings if you, say, exceed a certain force threshold.
A threshold mentioned in the source, implying risk.
Yes, implying risk of, well, potential tissue damage inside the cochlea. It directly links your action, quantified by that MN number, to a safety outcome.
So it's making the abstract idea of being gentle very concrete. You see the number, you see the warning. It's direct technical feedback.
Precisely. It's not just about the movement. It's quantifying the interaction forces at a micro level. Very technical.
And it doesn't just give you that live feedback, right? It tracks your whole attempt.
Correct. There's also an insertion metrics chart, typically top left according to the source. That's where chart.js comes in.
So that plots the data over time.
Yeah, it plots depth, force, and also speed throughout your insertion attempt. You can apparently resize or collapse it.
So you look back and see exactly when things went wrong, or
Right.
see where the force spiked.
Exactly. It provides that historical context to your actions.
Yeah.
Really useful for learning. You can see the trends, the correlations between speed, force, depth, and those warnings.
It's like a data log of your dexterity. Or maybe lack of it. The source also mentions a play-pause button.
Ah, yes, for automated insertion sequences. Probably helpful for showing an ideal insertion, maybe different scenarios.
Right, so you can compare your attempt to a perfect run.
It seems like it.
Yeah.
So you put all these technical pieces together, the specific drag control, the 3D view manipulation, the real-time HUD with millim and MN, the safety warnings tied to force thresholds, the historical chart.
It all paints a picture of a tool designed to really emphasize the link between technical execution speed, force, depth, and a safe outcome.
Definitely. It underlines how crucial precision is and how exceeding limits, even by tiny amounts measured in millinewtons, has potential consequences. It's about understanding the numbers.
So stepping back, this deep dives into the simulator's technical guts. built with tools like 3.js and Chart.js, really highlights the complexity. It's not just about steady hands, it's about responding to precise technical data.
Yeah, it really drives home the level of technical precision involved in modern medical procedures, making something complex, quantifiable, and trainable.
Which kind of leaves us with a thought for you, the listener. This simulator trains users on staying below a specific force threshold measured in millinewtons to avoid damage.
Hmm.
So how might that idea, the concept of a critical safe threshold defined by specific numbers and units, apply to precision tasks you deal with, maybe in your work, hobbies, engineering, art, even just, delicate everyday things?
And how does actually knowing those precise numbers, the MN, the immer, change how you approach that test compared to just sort of vaguely being careful?
Yeah.
Something to think about.
That's right, something to think about or try it out as well. You can go bionickheels.com/cochlea insertion and try it yourself. If your parents wanted you to be a surgeon, a neurosurgeon, an ENT surgeon, or any surgeon, this is your opportunity. Then after using this tool, you can tell your parents, hey, I'm now a surgeon. Well, at least the virtual one. And if you are able to insert the cochlear implant without causing damage like this, then you get a certificate from bionickchaos.com. You can put it on your CV.